So, in part 7, we're going to continue looking at components of Wi-Fi network. We're finally finished with those access points for now, and we're going to look at controllers, servers, and switches. So, what's a controller? Well, it manages access points. It's basically a 1U box that sits in a rack, and when you plug an AP onto the network, controller automatically detects the AP and configures it based on policies that you write on the controller. Now, the controller needs to be on the same network as the access points, but you don't have to plug an access point directly on the controller, as long as it's on the same LAN or even the same WAN. And without a controller, you have to manually configure each AP, which is not fun. Or, on the alternative, you can use a cloud managed AP like a Meraki, and then you don't need a controller. You can just configure the AP through the web browser, and we talked about that earlier. So, the controller talks to the AP. All the traffic that hits the AP goes to the controller first over a VLAN, and assume you know what a VLAN is, and then the controller takes the traffic that it received from the AP and it strips out the management traffic and it sends the data from the user device to the switch. So when you buy a controller, you need to make sure it's powerful enough to handle all that user traffic. You don't want to mix and match controllers with APs. So don't buy, let's say, a Cisco AP and an HP controller, even though technically they work together. It's not a good idea. And as I said before, controllers are licensed for a fixed number of APs usually. So you buy a controller, it can run 20 APs or 50 APs, and if you have more APs, even though a controller can physically handle it, it's not licensed to, so you have to buy a license, which is not difficult, but it can be expensive. Make sure to factor in licensing. And then a server. You don't always need a server, or you might need 10 or 20 servers. That depends on what kind of application you're running, if you're running an application. So we're going to talk about applications later, but if you have one, then you need a place to put it. You can put it on a server, you can put it in the cloud. Cloud is a good option sometimes, and sometimes it's not. Depends on many factors. So, what does a server do in a Wi-Fi network? Well, it can manage users. So you could have a proprietary software, could use a Radius server, could have an Active Directory server. So it handles authentication. You can also use a server to manage the guest Wi-Fi. So if you're at a hotel or an airport and you connect to the Wi-Fi, you see a splash page that says accept terms and conditions. Well, the Wi-Fi does that. I mean, the server does that. It manages the authentication, and it manages the users, and it displays the splash page. Or you could also need a server for DHCP, so assigning IP addresses to the different devices that connect to the wireless network. And your application server might have to exchange user data with other servers on the network, and you can probably use an API or middleware for that. So what does a switch do? Well, you should already know that by now. If you don't, too bad. I'm going to summarize it by saying that it moves traffic between different network devices. If you don't know anything else, I don't know how you got this far. But A PoE switch also provides power. And if we look at our typical Wi-Fi network, we have a switch, and we have access points connected to the switch. And there are Cisco access points, they don't have to be. And we have a D-Link switch, but we probably should get a better one here. And we've got our Cisco wireless controller also connected to the switch. And we've got our application server also connected to the switch. And then we've got our router also connected to the switch and to the cloud, basically to the internet. So, do you need a switch? Yes, you do. Do you need a new switch? Or can you use an existing switch? That's a question you need to ask. You need to think about if the Wi-Fi is going to be a separate physical network from the existing enterprise network. So, if so, then you have to have a separate switch for your APs exclusively. Circumstance where the Wi-Fi is separate from the rest of the network, at a hotel. So the guest Wi-Fi is completely separate. It doesn't touch the hotel network whatsoever. So there's no way for a guest to get on the Wi-Fi, even with the best hacking, and get on the hotel's computers, because they're totally physically different. They don't connect at all. Even they have separate internet connections. So, otherwise, your APs run on the same network as the other devices, but different VLAN. So a switch will configure the APs to run on a different VLAN. And again, as I said a few times already, switches have to be installed within 300 feet of an access point. And that's 300 feet of cable, not 300 feet like drawn on a map. So make sure switches should have open ports to accommodate the access points and also PoE capability. And again, there's many different models and manufacturers of APs. Not saying you should buy a D-Link. Probably you shouldn't buy a D-Link. If you already have switches installed in your network and they're made by one vendor, then you can probably buy new switches from the same vendor. So companies out there like Curvature and whatever, they sell reduced prices switches, and they're refurbished. They come all scratched up and repainted. They work totally fine though. So if you're buying a switch and you don't know what to buy, think about this. PoE, obviously you should buy a switch with PoE. Then you need to look at the network capacity. We call that switching capacity. How much traffic can that switch handle? Just because a switch has 48 ports doesn't mean necessarily that it's going to be able to handle traffic from 48 access points, where each access point has 20 or 30 devices plugged into it and they're all hammering down on that switch. It's probably going to fail. And then look at the ability to plug in an SFP. So if you have a large network, your switch is probably connecting to a bigger switch somewhere down the road, and the connection between those two switches needs to be a fiber optic cable, and so you need an SFP. And then consider redundant power supplies. So your switch can have 2 power outlets or 2 power plugs, and they could be hot swappable, and maybe even add a UPS to your setup. And then consider getting a switch with gigabit capabilities. You don't want to buy a switch with only 10-100, and then you've got expensive APs out there that are handling Gigabit Ethernet. And then you also want to look at the stacking capability. What if you need more than 48 ports? Then you can add a second switch, and instead of trunking them together, you can use stacking cables. And we'll talk about each of these features in more detail in a second. So, yeah, you need PoE, as I said, because you need to power all your access points, and you don't want to spend the money, and you may not have the space or the outlets to buy a ridiculous amount of power injectors. And then, again, as I said, you need to consider switching capability, because you don't know, or you need to figure out how many devices are connecting to how many APs, and then how much traffic each device creates. And all that traffic is going down one trunk port on the switch down to your LAN. And so that switch needs not only trunk capacity, but also switching capacity. It needs to be able to make decisions on forwarding all that traffic in real time. And SFPs, we said an SFP stands for small form factor pluggable. There are many different types of SFPs, but basically they allow you to connect a fiber optic cable or a 10 gigabit Ethernet cable. And so these are very important when you have a lot of traffic moving. A single Cat6 cable may not handle all the traffic you have. Redundant power supplies are pretty important in large networks, and the reason is the switches run 24 hours a day, 7 days a week. They don't even have power buttons, so a power supply is a pretty common point of failure on a switch. And if you've got two separate power supplies and the power supply fails or a power outlet fails, you can just rip the power supply out and put a new one in, and your network continues to run without any interruption. Nobody even notices. The alternative is to have a switch with one power supply, and if it fails, then your entire network goes down, or at least a segment that's connected to that switch. So that could be, hundreds of people or thousands of people, and they'll be pretty mad at you. And you have to buy a new switch and hook it up and move all the patch cables over and configure that switch. That takes a lot longer. And so, also, Gigabit Ethernet is important. 100 megabits per second is not enough. Keeping in mind, there's no other option here. You can't get a 200 megabit per second switch or 300. You can only get either 100 or 1,000. And what do you need 1,000 for? Well, let's say you had a 100 megabit per second connection, and you have an access point connected to a 100 megabit per second connection, and you have 20 devices connected to the access point. That gives everybody 4 megabits per second, which is not very much. If they're all playing games or watching YouTube, whatever, they're gonna have a very lousy experience. And then stackable. So if you get a bunch of switches and connect them with stacking cables, now you have a bunch of switches acting like one big fat switch. And this is a good idea when you have 48, or when you need more than 48 ports. And yeah, it's not very difficult to implement. And then all the switches work together.